Okay, so now we are online. Oh, I got to shrink so the screen fits onto your projection. Is that good? Okay. So yeah, NA equals NA returns NA, all right? So it's the question, if you think about it, right? Let's say you've got, you've collected some information and something is missing, right? We're like, you have 10 people in the room, okay? And you got the ages of 8 of the people, and you're missing the age of person 9, and you're missing the age of person 10, right? And so you write down in your notebook, you're recording these things, you say person 9's age, NA. I don't have that answer. Person 10's age, NA, okay? And then somebody says, well, is person 9 the same age as person 10? What's your answer? You can't say true. You have to say, I don't know. I don't have the answer to that, right? If you say, is the person 9's age the same as person 5, who's 26 years old? You'd also say, I don't know, because person 9, that person's age is missing. So it makes sense that if we ask, is some missing value equal to another, equal to a missing value, that the answer is we don't know, okay? And it's just a missing value. So how do we check? Because we might say, I want to know, is the value missing? How do we check if the value is missing? Yeah, there's a function that says is.na, okay? Is.na, and then we put in na and we get true, right? So if we say a is na, right? A is na, we can say is.na a, true, okay? Is.na, and anything else is going to return it's not missing, right? So that's what we have here. Okay, let's we'll start there, and then we'll go to we'll get today's lecture. Oh, students had questions about like these slides that I'm posting online, and a student asked, can I post PDFs? And unfortunately, I'm not able to post PDFs. Everything gets posted as a R Markdown template, okay? And CCLA sometimes is weird, and if you click it, sometimes it'll download, and then if you click it, sometimes so. Sometimes it appears as like a text file, right? And so, but basically these are R Markdown files, and if it appears as a text file, the way you want to do it is you want to just create a new R Markdown document. It doesn't matter, just it's all blank, and then just delete everything in there, copy and paste the text of that R Markdown file, put it in here, and knit it, okay? If it downloads it as an R Markdown file, then that was Monday's lecture. Close this out. Then what you do is, once you have it, or once you copied and pasted this stuff, you're just going to go ahead and click knit. If it gives you errors when you're knitting, it probably means you're missing a certain package on your computer here. Okay, and then you'll knit it, and then you can open the document right here, and now we're ready to go. Okay, so we're going to continue on in our data structures in R. We just covered a little bit more on missing values. This is a recap. We saw these on Monday, and this is what we saw. NA equal to NA is missing. Is NA, that's true. And then you can fit in any type of, NA will go into any type of vector because there's different missing types, because the atomic vectors all have to be of the same type here. And what is the type of the default NA? It's type logical, right? Type logical, so it could fit in the most restrictive form. There's also the null object. The null object is not a missing value, but it's the null object. I don't have a better word for it. And if you ask the type of for null, it's going to say it is the null object. Okay. And then the way we check to see if it's null is we say, is it null? Is.null for the null object, and that's going to return true. Whereas if you ask, is it missing, is NA, it's going to kick back a warning. It's going to say, you know, you're asking me are we missing something? So is.na is it a missing value is what is.na is asking. And then null is kind of like, it's not a missing value, it's something that does not exist. All right? It's a little bit different, right? So if I'm going out collecting data and I don't get a piece of information, I would say that's a missing value. If I didn't collect someone's age information, I would say the person's age is a missing value. It exists, I just don't have that information. The null is used kind of like this thing doesn't exist. And we would not really use that in terms of data collection. It's a null object, okay? And so if you were to try to insert the null object into a vector, say you have 4, 5, null, 3, there's no point in putting this there. This thing is exactly identical to the vector 4, 5, 3, okay? The null is just something that just does not exist, okay? And if you try to do operations with the null, like you add false to null, you're going to get back a 0 length vector, okay? So if you get something like integer 0, logical 0, character 0, this means you're getting a vector of 0 length. So we're expecting values of integer. Why is it that when I do null plus false, I'm getting an integer return? It's the operation addition. The operation addition coerces things into numeric types, right? And it's going to coerce into integers first if it can, and then if that doesn't work, then it goes up to doubles. But the plus operator coerces values into integer type. And anyway, you try to do something that doesn't exist plus the false value, you get a 0 length integer vector. It's a little bit strange, but it's kind of like times where you'll get back null will be asked, you know, what are the dimensions of a atomic vector? Dimension is an attribute that only exists for things like matrices and data frames and things like that. And if you ask, what are the dimensions of a vector that doesn't have any dimensions, it's going to return back null. Right? So here, we'll say A is the digits 1 through 4. Okay. And if I ask what are the dimensions of A, they will say that thing doesn't exist. Oops. Okay. Okay, we covered element-wise operations and recycling elements. Let's talk about lists, okay? Lists are vectors. They are generic vectors, and they are one-dimensional, okay? And you can put any kind of R object into a list, okay? So a list can contain character vectors, it can contain logical, numeric, logical, integer or type double, floating point ones. You can even put in functions, and you can put in other lists, okay? So inside a list, you can nest other things. And this is what appears when we do that, okay? So what is the length of this list here? Well, the length of this list is a list of length 4. There are 4 things in the list, even though the second object in the list itself has 2 elements in it. and the third object in the list has 4 elements. The list itself has 4 objects. And if we ask, what is the structure of the list? To get the structure of a list, you type in str and the list's name, the object name, and it will say it's a list of 4, and these are the 4 things. The first thing is a character vector, the second's a logical vector, the third's a numeric vector, and then lastly we have a function. We have a question.
Why are lists one-dimensional if they can have like a hierarchy, whereas like data frames and matrices have multiple or 2-dimensional?
Right. So the best analogy for a list is think of a list as a train. Okay, and in the train you have different train cars. You've got different boxes. Okay, and within each box you can have stuff, right? You could have another train inside one of those trains. Like you can have a little train, and inside of that train you can have another train, right? So there is a hierarchy. You could have stuff inside each train box, but the overall object, the overall train, is one-dimensional, and there's definitely we're not taking I don't even know what this would look like. We're not taking a rectangular train thing. We're just taking a line of train cars. Each box has its own thing. And within each box, you can have different stuff. But the train itself is one-dimensional. Okay? So you can think of it that way. So yes, if we want to nest a list inside a list, that is allowed. Okay? And we would say the list is not flat, it is still one-dimensional, okay? So here I'm creating B, which is a list with the objects 5 and 12, and C is a list with only one thing in it, 13, and A is going to be a list of B and C, okay? So here's the question, what is the length of list A? It's a length of 2. Okay, it's a train. You've got 2 cars in your train. Okay, inside the first train car, what do we have? We have another train. Okay, and we have a list of 2 inside there. Okay, so here, if we ask what's the structure of A, the top level structure is that it's a list of 2. Okay, and the first thing itself is a list. And then the second thing is also a list, but it's a list of 1. Let me just change this just ever so slightly. As if this wasn't bad enough, we're gonna just make it not worse, but okay, so I've got this. I'm going to just change this a tiny bit. We'll call these, we'll call this A, B, C. So we've got D, E, and F. All right, and then we'll do D and E. Okay, and then instead of list, I'm going to just do C. All right. Okay, so what is the length of, if we look at the structure of F, it's going to say it's a list of 2, and notice the difference between, okay, so I've got A and I've got F, and if I ask the structure of F and the structure of A, okay, so F, because the difference here is that this thing is not a list of 5, 12, it's a single vector of 2 elements, 5 and 12. This is treated as one object, okay? Over here, this is a list of 2 separate objects. You've got the object 5 and the object 12, okay? And it's actually a numeric vector of length 1 with the value 5 in it, and a numeric vector of length 1 with the value 12 in it. Here we have one object. It's a numeric vector of length 2 with the values 5 and 12. And so when we look at the structure of F, it is still a list of 2, but the first thing is just a numeric vector. If we look at the structure of A, it's a list of 2, but the first thing in it itself is a list of 2 with objects 5 and objects 12. Okay. And if you guys get this, I think a lot of the mystery surrounding lists can be explained. I mean, and of course, the first time you see all of this stuff, it is confusing. Okay, there's no. I'm not denying that. Okay, but does that make sense? Okay. All right, and then if I further just did this. And so here, if I do structure of F, it's just a list of 2 different numeric vectors. So throwing something into a list makes it a list. Okay, are we okay? We're just going to keep making our lives worse here. Okay, here, what do I have? I've got list X, okay? List X, I am saying we're going to throw in list 1, 2, and then vector 3, 4. Okay, this is a list of length what? What's the, I guess the answer's there. It's a list of length 2, okay? The first thing itself is a list of 2 with the values 1 in the first thing and the second, and then the next thing being 3, 4. Let me see, probably. So X is there, and the structure of X, this is what we have. Okay, let's keep in mind here, so I took the list 1, 2, and the vector 3, 4, and I put those into a list. What would happen if I take the list 1, 2, and the vector 3, 4, and I put that inside something here, C? Okay, so C is a combine operator. It kind of just sticks these things together. What we end up doing is, what happens here? I get back a list of 4 with 1, 2, 3, and 4. Now, why did that happen? Okay. What happens when you stick things into C and you had different data types, like you had a logical and a numeric, integer and a double float? What happens? It coerces them, okay? And that's what's happening here, right? What we have is we've got a list type, which is actually even less restrictive than the character data type, okay? We've got the list data type, which is the least restrictive because you can throw whatever you want in there. And so when we put this C combine here, what it's doing is it's going to coerce all of these things to the least restrictive data type, which is a list, and it throws it all in there. Okay, and so we end up getting these things 3 and 4 get coerced into a list, and we get that. This is while it follows the rules and makes sense, it is probably may not have been expected. Okay. And generally, when you write your code, you want to do simple operations, and everything is going to be expected, right? And everything can be followed along. And so while it's not, there's nothing explicitly wrong about this. Probably, if you want to come back, if you want to write your code and then revisit it 2 months later and know what you were doing, it probably is worth taking. Writing like 1 or 2 extra lines of code, so it's very clear what's going to be happening, so you're not caught off guard by this, right? So this is probably not best practice. It works this way, but probably not best practice. Okay. Are there any questions about these list operations and just using the list right now? Okay. With lists, a nice thing is you can name the objects. You can give each train car a name. You can actually name vectors as well. But here we're going to we've got our example is a list of 3. It's got A, B, and E. And B itself, inside that train car, is another little train with named cars C and D. Okay. And if we want to reference any of these things, we can say examp and use the $sign notation to say I just want the thing that's inside that first train car, and we do $A. Okay, and it will say, oh, inside there you've got the value 1. And if I say, what is inside B? Okay, we'd look inside there and we'd say, oh, there's another list. There's another train inside that car. And we've got C and D. Okay. Whereas if we'll go to the top level and we say, all right, what's in train car C? That train car C doesn't exist, right? We've got A, B, and E. And train car C is something that exists inside train car B. So if we just say from the top level, what is C? It's going to return back a null. It's going to say that thing doesn't exist. I only have A, B, and E. If we want the value that's inside this, we have to say look inside object B, and once you're inside there, look inside object C, and then it can return it back. But you can't go straight to a lower level. You've got to kind of give it the path per se there. Okay. And then this is cut off, but we can imagine what that's going to return. It's going to return back the vector 4, 5, and 6. Okay. We have attributes. Attributes are, I don't know, we can call it metadata that is attached to objects in R. Probably the most important cases of attributes are the class of an object, the names that the object carries, and dimensions of that object. Okay? And those things are special, but technically, it's whatever you want to be can be an attribute. Okay, so it's kind of as if you just have a separate sheet of paper that just you can throw extra information and link it to the object that we're talking about, and you access the attributes by using the attributes function or the function attr. Okay, so here I've got the vector with the values 1, 2, 3. So this is a numeric vector or a type double vector, but I've named the each element L, M, and N. So I've named the first one L, and the second element M, and the third element N. Okay, and so if I say what are the attributes that exist for X, it's going to say you've got names, and it's a character vector. The names are stored as a character vector with the letters L, M, and N. Okay. The attributes themselves are stored as a list. So if we ask, what is the structure of this thing that comes back with the names? That is, it says it's a list of 1. Okay? And list being the most least restrictive data type, you can throw in any kind of piece of information. You want to throw in a paragraph of text, you can do that. Okay? This got cut off again. So here, so we got X. The attributes of X are that. It's a list, and then and if you use the attr function, you're saying go into the attributes list and find the object named names, and it will return back the vector L, M, and N. Right? So or you could do attributes of x $ names, okay, and that will also return back what you have. Okay. If we wanted to, we could modify that. So right now, this is just a character vector, and I could say, you know what? Inside there, I want to take the letters A, B, and C. Okay. And so now if I ask for the attributes of x, I have A, B, and C, and if I print out x, it prints it out with A, B, C. Like that. I guess I did it a little bit. You guys are familiar with the letters vector, the internal letters vector in R, maybe? So it can be like if you had to name a bunch of things A, B, C, A through Z or something, it would be really annoying to have to type in C, quote, A, quote, comma, quote, B, quote, comma, quote, C, you know. That's annoying. But you can do letters, and you hit enter, and it's this vector here, okay? And if you do all caps letters, it's the all capital letters. So if you just want to like name things the 13th through 18th letters, you can do that, and you can just treat this vector. So it's just a little shortcut there. Okay. So anyway, I used letters 1 through 3 to rename the names in the vector x. Okay. And then you could, again, because it's just a list with arbitrary data, you can throw in anything else you want. So here we're going to create a new attribute called my_attribute, and we're going to put in this is a vector, right? And so we do that, and then x now carries this information. So here we'll do this. X has this, and if I print out x, it's going to say, it's going to print out 1, 2, 3, ABC, and then it's going to say, hey, you also have this other piece of information that says this is a vector, and then if you want to add even more stuff to it, I'm going to call this, you know, my feelings, and we'll say, I'm feeling great, it's a beautiful day. It's worth 5 exclamation points. It's there, okay? It's just, you can throw whatever you want to put into the attributes field, right? There's no rule against it. You want to throw in a vector in there, other matrix, it's fine. It goes into the list. Okay, and that's that. However, most attributes are lost when we modify the vector. So if I take x and then I subset x down to just the first letter, and I say we're going to store this as k, all right? And we look at k, and we ask what are the attributes of k? All of my feelings got wiped out, okay? Because when I modified that vector, they're gone. They're still part of x, but because when I subset x to just the first element, everything got lost. The only thing that it kept were the names, and that's just kind of what happens. Is that the only attributes that are not lost are kind of these most important ones, being the names, the dimensions, and the class. Okay, and if we want to access these are so important that we came up with our own functions that are just shortcuts for these exact same things. So this function and this function are exactly the same. And in fact, if I ask for the function dim, oh, I guess that's not, maybe, okay, I guess they're primitives. But these functions are pretty much exactly the same as asking for the names field in the attributes list. Okay, so you can ask for what are the names of x, and it will return back this, and what are the names in my subset vector k, and it's just got one element of a here. So I guess this is what I showed you. If you look at the attributes of x, it's got the names and it's got kind of the attribute that we made up. We can, if we subset that, however, the extra attributes are lost, only the names are preserved. The names, dimensions, and class. So when we're, if we want to give an object some names, we have a few ways of doing it, okay? We can do it when we create it, just like this. Or you can create a vector. So here we're going to create an integer vector, 1 through 3, store that as x. And then we're going to go back and just modify and say we want to give it some names and give it the vector ABC. Okay. We can also create a copy, and here we're going to create a copy of the vector and store it into y, and we're going to use the function setNames, taking the elements in x and providing it the names a, b, and c. So these are just a few ways of doing the same thing. Names don't have to be unique, so if you want to name multiple things a, that's fine. But if we're going to do character subsetting, which is probably the main reason why we want to use names, it's useful to have unique names. Okay. And not all elements need to have a name, and so if names are missing, names will return an empty string, and if all the names are missing, names will return null. So let's just start over here. So we'll do x is going to be 1 through 4 here, and then we'll do names of x, and I'm going to just give it the letters 1 through 3 here. Okay. So if I print out x, what's it going to print out? X is the values 1, 2, 3, 4, and it's got the names for the first 3, a, b, c, and then the last one is missing here. So if I say the names of x, it's going to say I've got the names for a, b, and c, and then the last one, the name is just missing. Whereas if I just do y is 1 through 5, okay, and I don't have any names for it, and I ask what are the names of y, it's going to say no names exist. They don't exist at all, so we get back a null. All right, is that okay? Names for vectors. We also have factors, and you might have interacted with factors already. We can use, in factors, we have an attribute called levels. All right, so let me create this factor here. Okay, and then if we have a factor, we get a, b, b, c, a, and then the levels a, b, and c. Okay, so here it kind of goes through and says what are kind of the unique values that it sees in this character vector, and we get back the levels a, b, and c. Right? Notice that if I just took the character vector, and let's call y this thing, and I print out y, it puts quotes around each of the elements to indicate that this is a character vector. If we look at x, we don't see any quotes, okay? And if I say type of, for the character vector y, it's going to say type of y is character. What is going to be the type of x or factor? Yeah.
Integer.
Yeah, the factor is actually an integer vector. Okay, now how is that possible? So if we ask the type of, it's an integer vector. The class, so the class, it's a special object type, saying that it's a factor. And if we ask for the levels of x, it gives us back the levels that are stored there. What's going on is that underneath at the underlying level, the vector is stored as an integer type. So if I use the command print.default on x, which means print using the default method, print this out for the actual type, it's going to print out 1, 2, 2, 3, 1. Let's compare that to what x is, okay? And it's got 1, 2, 2, 3, 1, and when we if we have that correspond to the factor, it goes A, B, B, C, A, and we can kind of see how that works. And so what it's doing is that inside the memory, or inside our system, it stores the values as integers here, and then it has what those integer values correspond to in terms of the levels. And so it stores the levels here as A, B, C. If I wanted to, I could take the levels of x, and I can say, you know what, let's take this third one, C, and rename it to California, okay? And so now if I print out the levels of x, I've got A, B, and California, and the underlying vector, if I do print.default on x, it's still 1, 2, 2, 3, 1, but now when I print out x, I've got A, B, B, California, A, right? And so here I've just got the levels A, B, and California. So it's basically, we're just coding things into numbers, and then when we print this out, we just look up what do these numbers actually signify. Now if I mess things around, if I say what are the levels of x, and I do this, and we're going to do levels of x, and we'll just reverse the levels of x. Okay, so here if I take the levels of x and I reverse them, okay, so print.default, so the underlying integer vector is still 1, 2, 2, 3, 1, but the levels of x are now California, B, and A. So what will this look like when I print it out? Now the 1s correspond to California, so this becomes California, B, B, A, California. Right? Does that make sense what's going on? So we've changed, the underlying vector is still 1, 2, 2, 3, 1. That's the underlying integers, but we've changed up what they correspond to in kind of the levels attribute. So anyway, other things with factors, once you have the levels defined as A, B, and C, you can't go and insert. You can't just change it into something like this. It's going to say this is not a valid number or valid thing that's allowed. So it's going to generate a missing value. Okay. Other things. Oh yeah, factors are actually integers. We covered that. If you try to combine factors, it's going to just combine the underlying integer vectors, which when you create the first factor, you get a 1. You create the second factor, also a 1, because there's only one level in each of those. And when you combine them, it just says you're combining two integer vectors of value 1 each. So that's going to give us a problem here. And you know, they're useful if you know kind of what values you could be expecting here. So here's an example where using factors might make a difference. In general, yeah, if you've got categorical variables and you know what categories to expect, then factors make sense, okay? And in general, if you've got a categorical variable, it's always a good idea to include an other category, okay? Because you might think that these are just the levels that exist or the different values that exist, and then something comes along that's different, and you need to be able to classify that or keep that, and so you should always have kind of an other or an other category. Okay. Sometimes you end up dealing with factors and you weren't expecting to deal with factors. Okay, so you might have like a value of numbers, a column of numbers, and then you're reading in some kind of CSV file, but maybe in that CSV file, to indicate that you have a missing value, they put in a dash rather than NA. Okay? And so when R sees this, it's going through, it sees all these numbers, but then it comes across the dash, it goes, uh-oh, this is character data, and it's then going to coerce everything into characters. Okay? And then the default behavior of R is to take a character column and turn it into a factor. All right? And so this definitely, you know, can make our life hard, especially, let's say I have 1, 2, 4, and a dash here, okay? And then and if we turn this into a factor, okay, this is what we get, okay? And you're going through and you're doing your stuff here, right? And we say, okay, what's the mean of 1, 2, and 4? 7/3, right? But if I ask, what's the mean of A? Well, okay, it gives me back at NA, so we'd say mean.NA, and I do NA.RM equals true. Right. I don't know what's going on here. Maybe I'll do as.numeric A. Okay, so we have this. I say as.numeric. Oh, you know, wait. Is this? Okay, this is actually. No, sorry. I've got the factor of A, and we'll call this B. So let's say we're dealing with this factor here. And if I do as.numeric on this thing, what do I get? I don't get 1, 2, 4 and missing. I get 2, 3, 4, 1. What happened here? Well, keep in mind that the underlying as.integer is it's storing these things as numbers, right? And so anything that corresponds to the dash is actually a 1. This is actually a 2, this is actually a 3, and this is actually a 4. Okay? And so sometimes this happens, and then you try to do things dealing with the numeric vector, and you're getting results that are totally different than what you might expect. Okay? And so basically, when you're importing data into R, you want to make sure that you don't treat strings as factors. So set that to false, and that should help out. Okay? We'll end here for today, and then we'll resume on Friday.